Okay. All right. I think everybody's here, sort of, kind of. Um, let's kind of kick things off here. All right. Going to do just a brief kind of topic today, because we want to leave some time for people to use this time for their projects, kind of some studio time. And yeah, but we do want to introduce some stuff for those of you who are kind of wrapping up projects. Hopefully, you can use this. You could use this in your current project if you want some of these things, or if you want to wait and use them in your next project, that's certainly possible as well. There's lots of different ways to do this. There's always with programming. There's always a dozen million different ways to try different things. So, without much further ado, I will try to transition to, let's see here. Nope, not that. This. Events. Here's the main event. So, events. You may have heard of them. Hopefully, at some point, have heard about them. What are events? Events are basically in your program when you have an event. Event happens. Remember when we clicked buttons? You clicked a button in the Unity interface, and there were certain types of events. There was an on-click event for that button. Or perhaps you had a collision and you had on collision enter. These are events. These are things happen, and you want to have some code called in response to an event. So something is some sort of happening. Now, so there are a bunch of different ways, and it can get a little confusing in Unity, especially Unity and C Sharp, about sort of the difference between C Sharp events and Unity events and delegates, and a lot of different terminology, and then how that kind of plays into the whole thing with classes and so on. So I'm going to try to introduce them today in sort of a practical sense. But we're going to cover them in more detail later. I'm going to show you some examples of one really, really simple example of using events today that based on the Scarecrow version of the game that I made on Monday. So let's see if we can jump into that. Events. So far for talking between classes, and I don't mean in between the classes that we actually attend, but for talking between classes, we have we have usually been using, sorry for the typo, explicit direct object references to talk across objects. So you have to know what object it is. You might say, oh, player.controller or player controller dot get component of type, find the script, find the particular variable in that script that's been set to public and manipulate that, or perhaps you called on Apple destroyed, which is set up a specific external publicly accessible member function or member field, and we refer to those as being sort of direct object sort of based references, right? But sometimes we also have been using this kind of static version, right? So if we didn't want to go through all the jumps of saying, okay, find a particular game object, then find a particular component on that, and then use the field or a method or some sub variable on there. Sometimes we have these static fields or methods that exist across all instances of a particular class. And if that's the case, we can directly reference that as well without having to go and step through, which instance of the class and find it and so on. So that's another thing that's we've been using to talk between classes that way, and that's a little more direct. But it's also more specific to the cases where we know that there is only one particular instance of that object, one kind of global way of touching that variable or calling that particular method. And it has certain limitations that we've seen in some of the examples where we can't look at things that are particular to an instance and so on. It has to be kind of a global sort of thing. Very useful for that. Whoops, what happened there? But is there a better way to communicate? That's the question. Now, better in quotes, of course, because better conceptually better. We like to think of things in what in C Sharp, in object-oriented programming, we love to sort of use the cleanest, most elegant, most object-oriented, encapsulated, pristine way, of course. But Sometimes that's not always the case. Sometimes it does make sense to have a static version or use a direct access and so on. So there's no one perfect way, but a lot of time we consider kind of events to be this better way to communicate. And at the very end, I'll say why this is often considered to be the better way to do it. So let's talk about events in general. Um, so let's see if I get this right here. All right, events. They are used by one class to notify other classes when some specific action has occurred so that those other classes can execute some desired behavior. Okay, so there is this shared notion of some type of event, an on click or on this certain action, on this certain event, perform this certain action. So because it's sort of action based, you can kind of virtualize it a little bit. You don't have to know really kind of specifically what happened. You just know that it happened, right? It's a specific action, but you don't know, oh, this variable changed, this thing printed out, and so on. It's just you know something happened, and you have some bit of code that is probably going to get called in reaction to that. Okay. Now, so far, we have been tapping into events usually handled by Unity, like the collisions, the button presses, frame updates, and so on. Those really are events. A frame gets updated, the update function gets called, and you do everything you need to do in your update function, right? So you really have been using events kind of seamlessly. You're using the events that are provided already in Unity and already kind of laid out in specifically the mono behavior, right? The class is what's implementing those events and allowing you to override those events and so on, right? Inheritance plays a big picture in a lot of the way that Unity uses events, and we'll get even more of this. This is meant to be kind of the brief introduction today, and inheritance is a longer topic. I want to leave more time for today. So we also, of course, we want to be able to set our own events to be triggered. Otherwise we wouldn't talk much about them, right? So we can set our own events to be triggered, and you can do it in a couple of different ways. Like I mentioned, there is this kind of general concept of an event, and there's also specific Unity events that we may want to use since we are in Unity after all. But there's definitely some overlap between them, right? In general, we sort of follow this pattern, this game or programming pattern called a publisher subscriber. This is sort of related to you. So you may have heard of this publisher subscriber kind of pattern. Events in general, they follow this, right? They have a publisher, the person who kind of raises, or the code that raises the event, that causes the event to happen. It's the thing that says, okay, this happened. And then the subscribers who are listening for that event to occur. It's like if you subscribe to an email list, you don't control when the email list happens. The publisher does. The publisher will send out the email, and then everyone who's a subscriber will get that email, right? They'll get the result of that action, that send, right? So quite often you hear about events being in the context of this publisher subscriber sort of pattern, being part of that. All right. So normally, we'll say this. I'll say, there's always that little asterisk. Perhaps there might be some ways to break this, but normally an event will only have a single publisher, but quite often it will have any number of subscribers. So usually it is a one-to-many sort of relationship, right? You have one event that happens and multiple things that will be listening for that event to happen. Okay. And even if you get into some weird circumstances where maybe you sort of have these multiple publishers, they're really still raising a single event, right? So there's a single event that gets raised, and then lots of subscribers hear about it. Okay, how that event gets raised, we can be a little bit hand wavy with regards to whether that's a single publisher or not. But there's a single event that causes lots of subscriptions to be raised, right, or to happen. So an events publisher generally does not have a direct reference to any of its subscribers. It doesn't know who the subscribers are, other than that they appear, that they're in a list of subscribers. So it doesn't know or care what the other classes are. It doesn't know or care what other classes are listening to that event, right? So it just says, okay, here's my published list. Here's my list. Here's an event. Do you want to publish? Do you want to subscribe to it? And if so, you will be called when this happens. But it really doesn't know specifically what that class that's subscribing, what it's going to do based on that. Again, it's sort of like with the email. Someone sends, a publisher sends out an email to an email list. Everybody gets it. The publisher doesn't care what your reaction to that is going to be. It just knows that it's important to make sure you got that email, right? You get that, then you do whatever you want to do with it, right? So that's, again, sort of that relationship. All right. Now, to talk about events, we got to at least mention, because these will show up a little bit in some of the syntax, these things called delegates, which is sort of the C# secret sauce for events a lot of the time. Okay, we don't have to know too much about them. It's best for now just to at least know that they exist and that they are kind of behind the scenes. Often they're behind the scenes. Sometimes they kind of creep towards the front, depending on whether or not you're using sort of the more raw events in C#, or if you're using the Unity events, these can sort of be hidden from you a bit. Okay, so think of delegates as sort of the C# equivalent of function pointers. So when we want to have something, we want to have some sort of function that can get invoked, but it's sort of going to be dynamic, right? It might change. We don't know exactly what it's going to be. So at runtime, we might add that functionality in. We don't know specifically what the function that's going to be called is. It's subject to change, right? So we use delegates when we need to have a function whose value may change or may get added. The code that's getting called in response to something may be changing as on the fly, right? So dynamically changing functionality without using conditionals. That's the other interesting thing about that. We don't have to say, if this, do this, if that, do this, if that, this, do that, and so on. Instead, we can just plug in a new value for some functionality, and that is the functionality that's going to be getting called. Like you might have something that is just print something to the screen in one case, but then another one, because in response to something else, you may have installed some extra code via the event structure, the subscription model, to say, okay, now I'm going to do something different in response to this. Instead of just printing it out, I'm going to also call this other code. I'm going to move my character around the screen. I'm going to explode. I'm going to do whatever. You can change that, right? So you just kind of, by plugging in new code through that delegate, you basically are kind of potentially modifying the structure of your executing code. So it's quite powerful, right? One of the main things you want to do, though, because they are so powerful, you'll see this a lot, that you want to be careful not to invoke them if they are null. Now, null pointers in general, you've probably seen, a lot of the time we want to check if we are referencing a pointer or an object or a reference to an object. We check it first. We see, okay, is it null or not? Sometimes bad things can happen if you try to dereference a null. Specifically, if you try to dereference or you try to execute or invoke a pointer or invoke a delegate that is null, bad things can happen. So you're going to see throughout the examples here that we're generally going to be checking our delegate, checking our event to make sure something is there before we invoke it. All right. So, all right, talked about it enough, a little bit. So let's show an actual example, and we're going to start with sort of the more raw C# delegate event sort of thing here. Okay, and I'm going to show one thing that's sort of fancy. I just mentioned that part about null checks, and the first thing you may notice here, you'll say, okay, all right, let's look. Okay, we create a delegate, we define a delegate to send with an event. Okay, so we say, okay, we want to say, here is our type of delegate. We have some sort of event to be triggered. It's a void. It doesn't take any arguments. So this is our type of delegate. And then we're going to create an actual event of that type of delegate, right? So it's like usual, we'll have some sort of placeholder for it, and then we're going to tie something to it. So public static event, here's the event. Event to be triggered, that's the type that we just created up here. and we said on event to be triggered, this it becomes our thing that will be invoked. This is our actual, it's kind of like when you're using a list. And then to invoke it, we say, okay, during our code here, maybe we want to raise this event, right? And normally to raise an event, you'll see we invoke it. Now here, it doesn't look like I checked this for null, which I just talked so much about and mentioned how important that was. But this is a special construct. You'll see this happen where you can say, okay, this little question mark here says, all right, check to make sure it is null before invoking it. So there's kind of a shorthand that you may see from time to time when you see this null conditional operator here, this question mark period. That means make sure this thing exists before doing what's associated with it, right? So that's one thing. So in this case, let's take that for granted and say this is the publisher, right? So the publisher sets up this event, and the publisher then raises the event. Remember, that's the job of the publisher. So the publisher sets up the event and then raises the event according to some triggering thing, right? And on the subscriber side, the subscriber has to do a couple of different things. All right, the subscriber has to subscribe to that event. And the way that it does that is normally it just adds itself or adds some method that it wants to have called. It adds it to that event. Right, so you see here, publisher.event to be triggered, on event to be triggered, there it is. We just added this event to that. So that will happen. And then importantly, we also remember that we want to remove that if for some reason we decide to go away, right? You have to, just like I suppose if you've ever seen, it's the cliche in the movies where somebody goes to somebody's house and they go to the house and they see this pile of mail out front because no one bothered to tell the post office that they went away on vacation or they left or the family's no longer there. It's mostly, you immediately know something's wrong because they're still getting all this mail. And in the case of publisher and subscriber, you want to be careful to make sure that your publisher knows not to keep calling your event if you are no longer there, right? So this is an important thing. You'll see I'm using on enable and on disable here, which is similar to how we managed our list in the examples that I've shown in terms of the creating apples or bags or whatever in our apple tree. As we created these objects that we added to a list, we might very well want to do things like take care of our subscriptions as part of that list, as part of that management as well, which is why I did it here in on enable and on disable. And then, of course, the important thing, this is where the subscriber actually does stuff in reaction to that event. Right? So this is where the magic really happens. Do something in response. And you can do whatever you want in there, right? Because you're just adding it to that list of functions that will be called as a result of that list. Okay. So that is the C# version. Okay. So I'll set this up as a potential exercise for you if you want to create a class that triggers an event when the player presses the space bar. Easy enough to do. And then you can have 3 other classes that all subscribe to that event, so they add themselves using this piece here where you said class.eventName plus equals function name, right? So each of them can do something in reaction to that one event. So the space bar gets hit, and all of the listeners, all of the subscribers do something in common, right? You can try that out. So that's the exercise. Now, how to use these. When do you want to use these sort of thing? So events are best applied as an alternative to things like the singleton pattern or our direct coupling of code, where we said, okay, this directly touches that other code and so on, right? It offers this decoupling. One part of your code can trigger an event without knowing or caring what is listening. Right? You don't have to say, okay, if this happens, now I have to make sure to change everywhere in the code where that happens and modify the code and so on. There's some housekeeping that you may have to do, but hopefully, if you've written things in clean ways, that you can sort of abstract what's going on and really limit it to just the fact that an event happened, do something in response to that event. That's the ideal kind of situation where they really don't know much about one another except for that event, that cause and effect behavior, right? So you can add new behavior to an event without going back and changing your existing code. So if you said, okay, now I want to add, another power up, for example, you don't have to sit there and say, oh, okay, well this power up and how does the parent know about the power up? No, you don't have to. You just say, okay, I add a new power up type. It becomes there. It's instantiated into my scene. I just add it to the event of the catch power up, for example, right? So it has its value in there. You can kind of add things and change your code on the fly, but it can make your code sometimes difficult to follow if you're not careful, because these things sort of happen automatically in reaction to something, right? It's sometimes difficult to say, okay, exactly what is calling my code because, well, I subscribe to an event, or maybe I have multiple subscriptions to multiple different types of events and so on. So it can be tricky, but it's also very powerful. So an example, when the player collides with an enemy, you could simply trigger an event rather than touch code specifically triggering this, that, and the other thing. So it might be, it could be picked up by things like the audio manager, the game manager, the UI manager, and so on and so on. So for example, if a player collision occurs, right, the player would just say, I collided, and then maybe there's an audio manager that says, oh, if you collided, I better play this sound. And there's a score that says, oh, well, if you collided, I better take one life away. Oh, if you collided, I should potentially end the game. Like, all of these things can install their own bit of functionality in reaction to the player collision event. That's the idea, right? Now, before I really just dive into the examples, trying to be quick, is I'll talk specifically, and this is a little bit easier to follow, I think, because we've actually done these, right? Unity has this more customized event system that you saw while you were working with the canvas. So you would add an event, for example, to this on-click, right? So a button has an on-click event, and you want to add some code to that, right? So you had some code in your class that you clicked and dragged and put into that event list, right? So now you think of this, okay, this is the event, and these are the potential subscribers to that event, right? So load scene was a subscriber to this on-click event, right? Now you notice in this case it actually did take an argument, which we can do as well. We can extend events to take arguments. But how do you use it? How do you implement it? How do you get there in your own code? You want to create your own events, your own Unity events specifically. Okay, so it's not too tricky. As a reference here, so there's a couple of different steps. You have, first, you want to add using Unity events.events to your script. That tells Unity, yep, okay, you want to use them. And then you declare an event. Say public Unity event on my important thing, on my semi-collision happening, something, whatever. This becomes your event name. This is the thing you want to have other people potentially subscribe to, right? And then you want to, in your code, in that class, you want to carefully invoke it in reaction to that thing. You can imagine in the code for a button, it's saying, oh, okay, if you clicked on, there's a button event that happened, you clicked on there, I better invoke everyone who's part of my subscriber chain. So it's basically going to say, okay, if I have subscribers, here's the written out version. So if there are subscribers to my event, then go ahead and invoke all of them, right? On my important thing.invoke says invoke everyone who's subscribing to that event, right? So that's what the publisher needs to do of a Unity event. So what does the subscriber need to do? Now, the subscribers in Unity, we sort of have a special name for them. We like to refer to them as listeners. So listener, subscriber, functionally basically the same thing. So we've added our listeners so far by dragging and dropping them in the Unity editor interface, but you can also do it explicitly in your code by saying unity event.add listener, and the Unity event here is the event you would want to listen to. Right, so in some cases, you're going to need to reference that according to the class, according to the object that is raising the event. So that's it's not usually going to be Unity event. I'm just using here as a placeholder. And you add yourself as a listener, and you add the name of the function that you want to add as a listener here. And then if you also need to, if you want to be careful, you can say Unity event.remove listener to take yourself out of that list as well, so you don't wind up, doing that multiple times. All right. And then to summarize again, like I mentioned before, why are we doing this? Well, one of the most important reasons to use events, listeners, observers, etc., is to decouple classes from one another. You want as little explicit interaction between classes as you can get away with. Right? You want your interfaces to be clean so that if you change one, you don't necessarily have to change lots of things in the other. Right? They maintain this very clean interface. Right? We'll learn a lot more about that sort of decoupling and other object-oriented techniques as we get into inheritance in the future. But for today, this is just the quick introduction. All right, so if that made any sense whatsoever, let's see, I'm going to go back to 2020. Nobody has typed anything yet. Nobody has panicked. I'm sure a few of you have your hearts racing and are short of breath at now, right about now. So I will do a little bit of an example here. Let's see. Let me go to a scene. All right, we're back over in Unity, or at least in what looks like. Well, no, we're actually in the C# editor. What am I saying? We're in Visual Studio, but we're not quite in Unity yet. How did I wind up there? All right, let's go get Unity back up and running. Where's my intro project? There we go. All right. So what I want to look at here, and I've done a little bit of reorganization. There's another kind of in-between lecture lesson I added on some reorganization and namespaces. So if you see the use of namespace in here, or my organization in here seems a little bit wacky, I encourage you to go back and check that one out. But that was specifically so that there might be things where I have my adventure game in here, I have my apple tree game in here, I have my scarecrow game in here, and so on and so on. And just in case I wind up with, say, a player controller that's part of my scarecrow game, and I also have a player controller maybe up in my adventure game, how does Unity take care of the differences between those? And there's a way to do that in C# and Unity called namespaces, right? There's a good thing to know about. So if you want to keep things sort of clean and separated, namespaces, go back and look at that one. All right, so if we go to the scarecrow scene, and the scarecrow scene looks an awful lot like an apple picker sort of game, and it plays an awful lot like an apple picker game. And here, let's see, I'm going to drop these bags and catch them. If I miss one, it goes away. Okay, general idea. Okay, so where do I want to use events in here? I won't make people raise their hands. I guess I could do that. It seems like a good place. An event that happens that you might want to. One thing that's having multiple events. I guess I'll just go quick to it. I won't make people guess. Inside my prefabs, in my bags that are being dropped, there's certain things that are happening, like a bag being dropped. There's two things that sort of happen as a result of the bag being dropped. The bag can either hit something, in which case it's regarded as being caught, or a bag can fall off the screen. And if the bag falls off the screen, we regard that as being destroyed. Right? So within the life of a bag here, there are two events, two possible events, I should say. They don't always have both. Usually it's one or the other. But the event is a uh, a bag is either destroyed because it fell off the screen or it is collided with something else. Now you look up here, we'll actually see, we'll look at our bag behavior script, and there's this cool thing. Now you see on bag destroyed, and it has a list that we could potentially add listeners to, or on bag caught, which is also a list, right? This is a little bit tricky to actually drag things in here. I could, let's see. Let me see if I could do this. Let's see. So, for example, well, I don't have a player prefab, so let's see. Maybe I could do. Let's see. Hold on. List is empty, and well, this is going to be something if this actually works. What I am interested in, of course, is the player controller, and let's see. Nope, not that one. Player controller, perhaps. Nope, I can't get it here. Let's delete that. Okay, getting access to another object is a little bit tricky from a prefab. Okay, we talked about that just a little bit because it doesn't really exist in the scene yet. It doesn't know about instantiated objects. Arguably, it should know about static fields, and there's probably a way to do that, but I'm trying to do this quickly. So that's the one problem here, right? There's no easy way for me to kind of drag and drop some functionality into these event lists here. So let's take a look inside the actual code that's associated with it, though, and we'll just see what's going on. And I've sort of implemented this all within one function here, which is our bag behavior. Okay. So to get that to show up, to get those two events to show up in the Unity editor, I'm saying using Unity Engine events. Right, so that it says, yes, I want to use Unity Engine events. I want to create some events. And then I create two public events. One public Unity event on bag destroyed, the other one Unity event on bag caught. All right. And those are raised, those events are raised specifically. Let's see, let's look for on bag destroyed. On bag destroyed happens, let's see, down in here, right? Which happens to be also part of destroy all dropped items. I guess I kind of just percolated it all the way through. It could have been up here in just that first one, transform.position y. So this is the when a bag is dropped, when it falls off the screen, right? So if it falls off the screen, if it falls lower than -5, then that's why we have to destroy this bag, right? And here's the raising of that, right? I used to directly call player controller.loseBucket. I needed to know things about it directly here in my code. So I would call lose bucket because we missed, you know, a bag fell to the ground, so therefore we lost the bucket. So, but now I'm not going to do that. I'm just going to say, okay, let's just raise that event. We're going to say if on bag destroyed does not equal null, somebody's subscribing to me, therefore I should go ahead and invoke that on bag destroyed event. And I no longer need this. I no longer say player controller.loseBucket. All right. Now, in the other case, we had our other event on bag caught. When does that get called? Well, that gets called in the collision, right? We say, okay, if the bag collided with something else, we say if on bag caught, we assume this is the case. If on bag caught does not equal null, we go ahead and invoke that. And you'll see I'm doing that in place of this other case here where I needed to know something specifically about the player controller. Right, so I'm taking out these direct accesses and instead putting in this part here where I'm raising an event. Okay. Now, of course, I do somewhere have to tell this, I have to get my player, which has those two things, I have to get my player controller to subscribe to these events. And that's where it gets a little bit tricky. And this is where this example becomes slightly contrived. It's slightly made up and where it doesn't, I won't say it falls flat, but it's slightly odd in that what I'm going to do, because the player doesn't really know about the bags. So I have to do this, I have to add the subscriptions sort of on behalf of the player. I have to do it explicitly, especially because this is in a prefab. So this part's a little bit janky, as they say. So I say, okay, whenever a bag is created, it says, okay, we're going to add our listeners here. We're going to go ahead and force our player controller, the lose bucket and add score routines, to basically be subscribers to this object's published events, right? So we add listener, and we say, okay, add score is going to listen for the bag being caught, potentially. And lose bucket is going to be used as the thing that listens for a bag to be destroyed, right? Does everyone sort of follow that? Is that, I have too many screens, I gotta like mouse across the whole world to say, is that relatively clear at all? Does that make some sort of sense? All right. All right. So there might be other circumstances. It'd be a little bit more clear. Like imagine we had, if the player were to be throwing something and the player needed to know, and this will become probably more evident in your future projects where you're like, okay, imagine the player throws a bullet or a projectile, and the player needs to know that projectile that I threw, did it hit something, right? That becomes a lot more clear. You could say, okay, I'm going to instantiate this bag and then put my add score into its subscription so that if that thing that I instantiated, which I now have a reference to, it'll make more sense, right? That thing that I instantiated, that I have a reference to, I can go ahead and subscribe to that, right? So if I throw 7 projectiles out there, I want to subscribe to each one of their on collision or their I got destroyed events, so I can do the right thing or modify my own behavior depending on what happened. So this is a slightly simplified toy, slightly odd version of it here. But the idea is the same, that someone has to say, all right, who is subscribing to the events, and then who is raising the events, right? So the players add to score and the players lose bucket are added as subscribers to this on bag caught event and on bag destroyed event, right? So if I were to look at my player controller, it just has this lose a bucket and add to score, right? And the player doesn't know really anything about what is causing those things to happen. It just does the right thing. It just says, okay, if someone tells me to lose a bucket, this is what I need to do. If someone tells me add to score, this is what I need to do, right? So I could have any number of instances that potentially cause the score to get added to, or other odd things to say, how many ways could I lose a bucket? So in the end, it looks exactly the same. But the nice thing is, if I were to come back into that code for my scarecrow, my bag behavior, I would just look at this start piece here and say, okay, here's where I'm saying, okay, that conceptually now, the act of catching a bag results in adding to the score. The act of a bag being destroyed results in loss of a bucket. I don't have to go throughout the whole code and try to figure that out, right? I can set up this relationship kind of explicitly without worrying about lots and lots of implementation details. So it does lend itself to to a nice organization as well, right? Otherwise, I might say, well, what if I adopt this as a good practice and say, okay, if I added something else, I had some other type of bag or some other type of projectile or some other type of thing that could add score, I would in its start routine do the same thing, right? So it enables me to set up a good practice, a good structure for doing that. So okay, on that note, if there are no questions specifically on it, we'll come back and we'll use that as we get into the shoot 'em up game and the platforming games and so on. Now, um, to wrap up, I guess I will stop the recording of that. Um, well, I'll leave it going just in case. With regards to games or projects 3 and 4, so want you to start thinking about those over the break. You don't have to necessarily start writing stuff. I guess you're going to be out for a week, hopefully doing something, or relaxing, catching up on things. Um, if you are doing a quite literal version of exactly what, following my code and just typing it in, making sure it works, like I said, I'm really kind of hoping for something above and beyond that shows understanding of what's going on. I know some people have been saying, well, I want to get the minimum done before the break because I do want people to, I want to know that we can move on from the project. So you can get sort of, a put a stake in the ground this week with regards to getting all the functionality and saying, yeah, okay, that's good for 85, 90% of the way there, and that's good enough. Okay, great. You can add another, so I'm going to let people earn another 10% basically on the project if they want to go above and beyond today, sort of to get to 100, not 110%, but as long as you've got 85% functionality by tomorrow, then you're in good shape. I just don't want people not handing in anything before the break. Okay, so hand in something before the break to show to me that yes, you've got, a good handle on things. And then if you need to add more, get that another 10% after this, we can go ahead and do that as well. But so by tomorrow at midnight, it is the deadline. So hand in something to put your stake in the ground to say yes, okay, I have been working on it. I've gotten this far, but you can go above and beyond. We'll add, you can potentially earn 10% back towards, or more than 10%, 12%, 15% back, as long as you've handed in something. All right. I just don't want people handing in nothing and just putting off the deadline entirely. That's what I don't want to see happen. Okay, some people asking questions. As I was saying this, as those words are coming out of my mouth, yes, there is already a submission point on LMS, and you can do multiple submissions there, but you can go ahead and submit to there. So you need to submit on LMS as usual, and also make sure everything is on Unity. If I'll ask if you plan on continuing, let me know. Okay, just so I can take that into account. If I don't hear otherwise from you that you plan on continuing, we'll work it out. So, yes, let me know. Say one way or another with regards to. I do expect if you have to have something to not be considered late. You have to submit something before midnight tomorrow on LMS so that I know, yes, I could in theory start looking at things and that what should be there should be the 85%. So assume that I'm going to start at least looking at the projects and downloading them at that point. I will be doing that. Okay. What I'm going to do is basically say, okay, I'm going to grade it as if that was the final version. And then if you've got something after that, let me know up until we get back so that, we can be good on that. Okay, but my main point, my main point was really what we're going to do with the next two projects is we're also going to do some more thought exercise up front in terms of what you want the projects to be, because I want you all, especially because it's going to be scoped much more broadly, is that we want to have a design for your games. Okay. Now the first one is going to be, the idea is that it be the kind of traditional shoot 'em up style game, which can mean, of course, lots of different things. Anything from a Berserk or an Asteroids or Enter the Gungeon is the one I love to point to. Any type of bullet hell game. Basically, the main mechanic that I think of for this one is that it is a top-down game, right? So that with regards to the way that physics would be involved, is physics may uh, impact things in terms of like how long a bullet stays in the air and so on. But the player movement is is in 2 dimensions, and by those 2 dimensions I mean more like north, south, east, and west, as opposed to left, right, up, and down. If that makes sense. So normally the last project is one where we're 2D platformers, so that our vertical motion is usually controlled by either jumping or falling, so that we have a little bit more interaction with physics in the player's control and under what the player has to sort of deal with. Whereas in the shoot 'em up game, physics may be resulting in momentum or angular momentum, or certainly things we have to deal with, but not, the player can't fall or fly. If that, you're moving around a two-dimensional playfield somehow, top down. And it could have a 3D, certainly either of them can have a very 3D look for them, right? So there's this gray area of what platformers mean these days. Platformers used to be this more side scroller kind of thing. So there's a little bit of room. If you want to be incredibly ambitious, you can think about designing something that covers both genres, and there is some sort of clear distinction. You get to this level and then things change. You jump in a vehicle, you go to a next level, and so on. If you want to make one seamless game that covers both projects, potentially project 2 and 3 and 4, that's cool. That's good. That could be great. So, but I do want you to be thinking about, designing the game, and basically within a week of when we get back, we'll talk a little bit more about what should be in the design. But within a week of that, we want to have, some sort of design. So now you can start thinking about, what assets you want to use. Look around the Unity asset store for things. Start thinking about themes and so on. And then within a week of us getting back, we'll kind of you will submit what will be then your design document. And the idea there is that you will be working from that in order to make sure it's going to be our little sort of contract to see, what in general what the game is going to be like, so that I know that I feel comfortable that you're going to be able to exercise everything I'm going to ask you to do in that game, right? So do think about sort of the top-down shoot 'em up one next, tank style motion or RPG, kind of roguelike top-down motion if you wanted, but think in those terms for the next one. All right, I'll stop blabbering on and on. That was about an hour's worth, which is more than I had bargained for, and I'll stop the streams, and if anyone has any continued questions, just let me know either in the direct chat or in a direct message. Okay, see you all later.